Welcome back to the deep dive. So if you've traveled recently or maybe just tried to charge your laptop and a phone from the same outlet, you probably run into this problem.
Oh, for sure.
Our power bricks, they just feel stuck in the past. They're
Yeah.
big, they're chunky, they get hot, and they almost always block the second outlet.
It's a universal frustration.
It is. So today, we're diving into the science that is finally solving this. We are unpacking what some are calling the miniature revolution in charging.
And that's all about gallium nitride, GaN for short.
Exactly. We've got a whole stack of sources here detailing how this technology works, and we're looking at it through a really practical lens, a product line called the Forcell Mini GaN III chargers.
Right. And our mission today for us and for you listening is to get past all the marketing buzzwords like fast charging.
Yes.
We want to give you a real shortcut, a deep understanding of the material science breakthrough, that's GaN, that is fundamentally changing the size, the speed, and, the safety of how we power literally every device we own.
Okay, so let's start at the very, very core of this. For decades, the entire electronics world has been built on one thing: silicon.
The king.
It's the king of semiconductors, absolutely. So why now? Why is silicon suddenly facing a challenger? And why are we all hearing about gallium nitride? I mean, isn't silicon good enough anymore?
That's the perfect question. Silicon has been just a phenomenal workhorse, but like any material, it's hitting a physical limit, a performance ceiling.
Okay.
I like to think of traditional silicon as a reliable, a two-lane road. It gets the job done, but traffic can only move so fast before you get jams and it generates heat.
Right, the friction.
Exactly. Gallium nitride is a newer generation semiconductor, and the key difference is in its actual material properties. We're moving from an elemental semiconductor, which is silicon, to a compound semiconductor, JHON. And that shift lets us just completely rethink how power is regulated.
So a different material. What's the specific scientific difference that I can actually see in a product I can hold? What's that primary technical advantage?
The single most impactful difference is something physicists call a wide band gap.
A wide band gap.
Right. Silicon has a much narrower one. Now, in simple terms, the band gap is the amount of energy you need to get electrons to flow through the material, and that dictates how high of a voltage you can run and how fast you can switch the current on and off.
Okay, that makes sense.
And because GaN has this wider band gap, it can handle way higher voltages. And crucially, it can switch much, much faster than silicon. If silicon is switching thousands of times per second, GaN can operate in the millions.
Millions. And when you say switching faster, what does that actually get us? Is that the key to making things smaller and faster?
Absolutely. The speed of that switching, combined with what's called higher electron mobility in GaN, translates into two huge wins for us.
Okay.
First, when a component switches faster, it wastes far less energy as heat. And less heat means you don't need those big, bulky heat sinks anymore.
Ah, those metal fins inside the old chargers.
Exactly. Those things took up all the space in your old charging brick. You can shrink the entire system down dramatically.
And the second win.
Second, because GaN is so much more efficient at switching power, the chargers themselves just have a significantly higher electrical efficiency. So the charger runs cooler, it's losing less energy, and it can deliver power to your device faster and more stably than an old silicon charger. It's a perfect example of superior material science in action.
So just to crystallize that for everyone listening, the efficiency gain isn't just a small bump. It's a genuine material science leap. It removes the need for big, hot components, and that directly lets the whole charger shrink without losing any power.
Precisely. It's a total system redesign that's only possible because of the semiconductor itself. That's why you hear people saying GaN is, the future of power electronics.
Okay, that dive into the physics makes perfect sense. The science really does dictate the size. So let's move from the physics lab to the practical application.
The real world.
Exactly.
Yeah.
Let's use this specific product line our sources mentioned, the Forcell Mini GaN III, as an example of what this GaN tech really enables for you, the consumer.
Good idea.
The key outcome seems to be the ultimate travel accessory. Real power, but without the bulk. Our sources stress that the construction is designed for minimum space. I mean, we've all dealt with those blocky chargers that take up 2, even 3 slots on a power strip.
Oh, yeah.
This new form factor is designed specifically to prevent that. It just fits easily into the tightest spots.
And this is what's so great about GaN. It's highly scalable. The technology is just so versatile across different power needs. This specific line we're looking at, it includes 6 different models.
6.
Yep, 6. They range in power output from a minimum of 20 watts all the way up to a pretty robust 45 watts.
That seems like a really wide range. How does that cover what people actually need?
Well, it basically covers everything you carry with you today. The smaller 20-watt models are perfect for fast charging your smartphone, even the newest flagships, or a tablet. But where the GaN advantage becomes truly revolutionary is when you look at those higher power models, the 45-watt options.
Right, that's getting into laptop territory.
It is. 45 watts is more than enough power to comfortably charge a lot of modern laptops, like a smaller MacBook or different Ultrabooks. And think about it. A 45-watt charger used to be a heavy, chunky brick. Now you can replace that huge laptop charger and your phone charger with one single compact GaN unit that fits in your palm. That versatility is a game changer for your travel bag.
And the practicality goes right down to the port layout, which is something users are really demanding now. The sources note that all the products in this mini GaN line have dual ports.
Right. They're usually set up as either a USB-C or, the older USB-A standard.
So you can charge 2 things at once.
Exactly. They're taking that tiny size and giving you the maximum charging capability in that one footprint. So one plug in the wall can power your phone and your laptop, or your tablet and your headphones. It just ends the fight for outlets.
Let's shift focus a bit from the physical size to the actual user benefits, speed, and protection. Because, let's be honest, the market is just flooded with chargers that all claim to be fast. What makes the GaN advantage translate into genuinely better speed and, maybe more importantly, better protection?
Well, like we discussed, GaN provides the raw capability for efficient power delivery. But speed is a two-way street. The charger has to talk to your device correctly.
The handshake.
That's it, the handshake. And these chargers do it by fully supporting the big industry standards, specifically Quick Charge, or QC, and Power Delivery, PD.
So for someone who knows a bit about this stuff, what does supporting PD and QC actually get you?
Think of it as a mandatory and very smart negotiation. When you plug in a device that supports power delivery, the charger and that device have a quick chat. They negotiate the perfect power flow, the right voltage, the right amperage, that the device can safely accept at that exact moment.
So it's dynamic.
Completely. Plug in a small phone, the charger delivers just what's needed. Plug in a big laptop, it safely ramps all the way up to 45 watts. Supporting these protocols means the charger can optimize power flow on the fly, and that gives you the absolute shortest possible charging times. It's intelligent power management, not just brute force.
Now, let's circle back to that efficiency point, the fact that GaN runs cooler. How does that help with the charger's own lifespan and safety? I mean, is it just that it feels less warm, or is there a real functional benefit there?
There's a huge functional benefit. That higher energy efficiency means fewer energy losses. Fewer losses mean less heat is generated inside.
Makes sense.
And when electronic components operate at lower temperatures, they have less thermal stress. This lets them perform at their peak efficiency for longer, which means greater stability, sustained performance, and a longer overall product life. A cool charger is a reliable charger.
Okay, that's a key point. We're dealing with a massive amount of power in a tiny package, so safety has to be absolutely critical. Our sources highlight that these devices have multi-level security features. I'm always a bit skeptical, because every charger says it's safe.
Right.
What makes GaN's protection genuinely better?
This is where the efficiency of the GaN system actually creates a safety buffer. Because the system is just less prone to heat instability to begin with, the protection features can be more reliable. We're talking about comprehensive protection against the main things that kill electronics: overload, overheating, and short circuits.
So it's a whole system of protection.
It's not just one failsafe, no. It's a deep system that's constantly monitoring the current and the temperature. If you plug in something with a faulty cable or a short, the protection circuits cut the power instantly. It protects your expensive phone or laptop.
And crucially, the sources emphasize that these features ensure a stable output voltage. Why is voltage stability so important for the consumer?
Stability is everything for the long-term health of your battery. When a charger delivers a fluctuating or dirty voltage, it puts stress on the internal battery management system of your phone or your laptop. Over time, that stress degrades the battery. The precision of a GaN system means the output voltage stays incredibly consistent and stable, which is a huge but often overlooked factor in making your device's battery last longer.
Okay, so we've got Superior materials, an incredibly compact size, blazing speed through smart protocols, and this really robust multi-level protection. What does this all mean in the bigger picture? Why is GaN becoming such a dominant force now?
I think it represents a critical point of maturity for the technology. GaN has moved past being an expensive niche thing. It's now scaled up enough that it's widely considered, and I'm quoting here, the future of power electronics. Consumers aren't really debating if they should adopt it anymore. They're just demanding the benefits.
So the demand is there.
Oh, the market appeal is incredibly strong. This particular product line, for example, is identified in our sources as one of the fastest rotating products in their whole portfolio.
Wow.
That's market proof. It tells you that the moment consumers see the benefit, the tiny size next to their old brick, they immediately choose it. It's an easy sell.
That rapid rotation suggests the difference is just really visual and impactful. Our sources actually included a great tip for showing this to a friend.
The tip is all about the side-by-side comparison. The real aha moment for people is when you place a compact GaN charger right next to a classic silicon one with the same power rating, say 30 or 45 watts. The difference in size is just staggering.
So you see it immediately.
You see it. Compact design, full power, full speed. That's the selling point. You realize you don't have to trade portability for performance anymore.
And I like that the versatility means you can really pick your solution. Knowing there are 6 models from 20 watts up to 45 lets you match the charger to your exact need. If you just need a small charger for your phone, you get the smallest one. If you want one charger for your whole desk, you go for the stronger 45-watt unit.
That's it. It's about matching the power to your devices without paying that penalty in size and weight. It's just the smart, long-term choice for anyone who travels or even just wants to clean up their desk.
Well, we have covered a remarkable amount of ground today. We've learned that gallium nitride is a major technological leap, a new semiconductor replacing silicon that uses a wide band gap and higher electron mobility to manage power just so much more efficiently.
A huge leap.
And that shift delivers 3 core benefits to you: an incredibly compact size, unbelievable speed by intelligently supporting protocols like QC and power delivery,
And safety.
and superior multi-level safety features that protect your expensive gear from overload, overheating, and ensure that critical voltage stability.
Indeed. It's really rare to see a material science innovation make such a quick and, tangible impact on the stuff we use every single day. It's a fundamental improvement, and it's definitely here to stay.
It seems like it.
So, before we wrap up and before you go look at your own charging brick, here's a final provocative thought for you to explore as you consider upgrading.
Okay.
Given that GaN chargers are built specifically to run cooler and more efficiently than the old ones, meaning they put less heat into your device and stabilize the voltage, how might the widespread adoption of this technology impact the long-term health and lifespan of the batteries and the devices we charge the most? I mean, if charging cooler and more stably equals batteries that don't degrade as quickly, what does that mean for how often you'll need to replace your next smartphone or laptop? It's a really compelling question about sustainability, all driven by a tiny piece of material.
That's a fantastic way to look at the longevity of our technology.
Well,
Thank you for diving deep with us on this miniature revolution. We'll catch you next time.